There we go. Let me highlight myself. Oh, it's me. And then the question is 5-6, number 24. Let me share this real quick. Let me move this over here. Shit. Oh my gosh. Oh, a whole nother semester like this after this one is gonna be crazy. All right. So here we go. Ah, shit. What was it again? 24. Okay. Find the X and Y intercept. Oh, find the X and Y intercepts. Okay. So how do you, well, the Y intercept is almost always the easier one, right? Especially if it's solved for Y, which it basically is. So how do I always find the Y intercept? How do I always find the Y intercept?
Plug in 0.
Plug in 0 for
X.
X. I love it. So stay with me now. Stay with me. This is important. The last math class I took, I'm almost certain it was math 696, but don't hold me to that. I can't remember what the hell number it was. I had an equation with about 15 letters in it, 15 variables, and they asked me to solve for the W-intercept. So what did I do? I made all the other letters 0. Holy shit. So that idea holds no matter how many dimensions you do a problem in. So just remember that. It's always that. How do you find the blank intercept? You make all the other freaking letters 0. Now, so that one's the easy one because the function's written in terms of X. So that you throw a 0 in for X, you get a fraction, you divide it, you're done. How do I find the, where am I at? How do I find the X intercepts? That one's not gonna be that crazy hard, but that means I wanna make the function equal to 0, right? What's the only way this type of thing can be 0? What's the only way a fraction can be 0?
If the numerator equals 0.
Yeah, if the top's 0. So then you set up 94 minus 2x squared equals 0 and you solve it. And that one's nice because you can directly get the x squared by itself, take a square root. Is that cool? So I'm not gonna claim that it'll always lead to easy things, but the first step is always easy. Make x 0 to find the y-intercept, make y 0, which means make the function 0 to find the x-intercept. Is that all right? Private chatter? Yes, okay, cool. It is always fine if it's not okay. I can always try to rephrase. Phrasing. Anybody else? Question? Oh, that's not gonna be, so the, let me see, did I forget something? Yeah, that was on the last quiz. This quiz is gonna be 5, 3, 5, 4, 5, 5. So if you have any questions from those sections, now is a prime time to ask. So there's not gonna be any finding vertices or stuff like that, right? There's not gonna be completing the square problems. Okay, hold on. Let me look that up. Let me see what you're talking about. Oh, do you guys remember? Okay. Oh man, I gotta keep moving everything around. Hold on. On the practice sheet that I posted, there were 2 problems that will not be on the quiz tonight because after I created that sheet, I decided to not have those. So let me show you. Remember, I was going to try out being nice. I don't think I like it. I'm going to probably stop. Oh, this is beautiful. Thanks, Canvas. You're so awesome, Canvas. Let's try this again. There we go. So these last 2, these 2, that will not be on the quiz. That's from section 5-6. So that will not be on the quiz. You're welcome. Okay. And but your question was about completing the square. There's no completing the square to do here.
Problem 4.
Oh, this one. Oh, why did I put that on there? That's so weird. Yeah, because that's section 5.2. Let me see something. Hold on. Yeah, because today is supposed to be 5.3 through 5.5. So did I put? I think I did. Let me see. Give me a second, everybody. Talk amongst yourselves. Oh my God. I should have checked my Wi-Fi. I don't know if I've got decent Wi-Fi or not. Oh, good. I didn't. All right. I didn't want to. Perfect. All right, good. I don't know. I really don't know why I left that problem on there. I'm really sorry. The quiz tonight is not going to include quadratic stuff. Brian is saying hi to all the peoples. He's trying to see who's not a people. Anybody else? Is that all right? Private chatter? I'm sorry I didn't understand what you meant, and that was my fault for leaving that problem on there. I'm very sorry. It's only going to be 5.3, 5.4, 5.5, which is finding the zeros, synthetic division kind of stuff, Descartes' rule of signs. Oh yeah, upper and lower bound stuff. Lists of possible zeros, all that kind of stuff. There seems to be, oh, go ahead, sorry. Was somebody?
Descartes' rule, I think that's how you say it. If you get 1, you don't put 1 or 0, right? You just put like 1 positive real root.
Yes, why? Why does it go down by 2? All right, this is an awesome, now watch, this is awesome. I'm so happy you're asking this because I was thinking about doing this and I forgot until you said that. So let me go to the board. As I knocked my chair over. I probably have to adjust it. Hold on. Get down here. So now watch. I'm gonna draw a shape without putting a coordinate axis on there. You could do it, Jeff. What do you got? So this is what's affectionately known as the butt graph. So it's just living out there. I don't know where the coordinate system is. If the coordinate system was right here, let's see. How many zeros does it, how many real zeros does it have? If this is the y-axis. Say again, sorry?
Would it have
Yeah.
two real
Two.
zeros?
You can see them right there. So now watch. What if the function, whatever the function is, what if I added enough to it to lift it up? So effectively, I lift it up like that. How many zeros did I just lose?
2.
2. Yep. So that's why, and what do the zeros become? They went from being real, and now they are, if they're not real.
They're irrational?
That's an interesting, I'm kind of interested that you said that because there seems to be a misunderstanding. Irrational are still real.
They're imaginary.
Imaginary, yeah, complex. So is that by itself? All right, so that explains why it's always got to change by 2. Now watch. Watch. The only time you're going to have a possibility of one real root is if I have something like this. One real root there. Do you see that? And if I move this down enough, then I pick up 2, and but I'm never gonna screw it. I don't know how to say that right. But basically, your complex answers are always going to be coming from, algebraically, they're going to be coming from, they're going to be plus or minus. So there's always going to be blah, 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 blah. Plus or minus, there's always going to be 2 of them. So trying to give you a graphical show. If you can move the graph up and down, you're going to lose two real, and they're going to become too complex. That's why I always go 3 or 1. So if you get one possible positive real root, you'd have to go down by 2, but you can't owe somebody a real root. It can't be negative number of real roots. Is that all right? Probably over-explained that one. Sorry. I'm going to take that as it's okay. All right. Now, a separate issue. There seems to be a misunderstanding about what real means related to rational and irrational. These two are separate from each other, right? Get out of there. Separate. But they all live within reals. So I was getting somebody that was telling me that the only real solutions was 2 and 3, but there was some quadratic thing that they could solve and get some irrational answers, which are still real. Are you guys all with me? The only numbers that are not real are complex, imaginary parts to them.
Like if you had a radical negative number, right?
Exactly. That's the definition of imaginary. So I don't have enough space here, but you ready for this? You ready? Let's see what shape. Here we go. Complex. This is where let's see. So it's A plus BI, where B, sorry. And then in here, real are A plus BI, where B is 0. So the real numbers are a subset of the complex numbers. Is that, some of you guys would be like, well, of course they are. Yeah, Garrett, right after class. It's going to be like last time, with one little difference, and I'll show you in a minute. Is that all right? Is that all right? I know nobody asked that question, but there seemed to be some confusion on some of the homework about how these things relate to each other. Okay. Anything else from homework stuff? If there's not, I want to talk about the quiz a little bit. Oh, sure. Okay. How would I show that something is an upper bound? You guys remember?
If you go through synthetic division and then they're all positive outcomes, then that would be an upper bound.
I love it. If you get nothing but positive numbers, then whatever this is, so if you divide it by x minus 7, right, but we say 7, then that would be an upper bound. If you have anything else in your list of possible rationals, you can just cut them out that are above 7, including 7 if it doesn't go in. Right? Now, something I didn't really make clear is if I do this by 7 and they're all positive and the last one is 0, then to be honest, I want you to realize something. Not only does that mean you can, you don't necessarily cancel 7, but this means you can kill, I really want you, this is where Descartes would come in, right? Do you guys see what I'm saying? Maybe? I don't think I said that to you guys. I don't know if you get that. Descartes, is that cool with the bounds? How does lower bound work? Before I change my track I'm on. Upper bound is when you synthetically divide and it leaves you with nothing but positive stuff, right? How would a lower bound work?
Alternating signs.
I'm sorry, do it again?
Alternating signs.
Yeah, alternating sign. Positive, negative, positive, negative, positive, negative. Where are we at? Yeah, we did talk about, remember we did talk a little bit about what if they were all negative? That would mean the same thing because there would be a negative I could have factored out at the beginning. Okay. All right, so those are the bounds. What about Descartes? I'm leaving him up here for a reason. What does Descartes say about something like, Descartes, I'm so sorry. Your name is all screwed up, I'm sorry. What would Descartes say about this thing here?
It has 0 positive real roots. It has
Yeah, it's
0
got
positive
no,
real roots.
I can almost hear you. Do I just
No
have my,
positive real roots.
no positive real roots, I like it. So if you do divide and it goes in evenly and you're left with nothing but positive numbers, you can cross out all of the leftover positive stuff. Does that make sense? I really want that to make sense. Every time you synthetically divide and it goes in evenly, that means your new function basically is this. So if Descartes says this guy's got no positive roots, then obviously you can throw all of them out. All right. Remember, there seemed to be a connection between Descartes and the upper lower bound thing. There really is. Okay, anything else, guys? All right, so let me show you something. Let's see if I can do this without giving away the farm here. Yeah, I think I can. All right. So what I've managed to figure out, finally, because I'm an old man, so all the technology you kids are putting together nowadays, don't understand it. I finally made it so I could put an actual copy of, I don't want to show it to you, but like the first quiz where I put a copy of the quiz in there. So you could click on this link and you could download a copy of quiz form, print it out if you want to, or if you scroll down, there it is, the quiz. So it's a little nicer because I was trying to type the stupid things in the text box and it kind of looked freaky. I don't know if you agree with me or not, the way the quiz was laid out. All right, so now it's not like that. So I figured out finally how to do that, which it shouldn't have taken me that long, but oh well, too bad. Does everybody understand that? Oh shit, here's the chat. All right, I gotta pay attention. Oh, all right, thanks, Jason. Good job, eventually. It's good enough for government work. Uh-oh, sorry. I also work for the government. All right. Anybody else questions? Okay. So you can read here, it's gonna work the exact same way. I am actually giving you an hour and 35 minutes. Okay, it's a little bit long. Yes.
Are we just doing like the first couple of questions because you didn't want us to do the last two?
Oh, no. I'm sorry. Let me make it really clear. I created this quiz to cover exactly what it's supposed to. You will do every single problem on this quiz.
Okay.
The practice one, I created it before I decided to not have 5, 6 on the quiz.
Okay. Got you.
Yeah.
Thank you.
Please do every problem on the quiz, though. Yeah. That would so suck. Okay. All right. So just to remind you guys, there will be, if you go into Canvas right now, you'll see these. You just won't be able to access them because you're not special like me. So this is where you would get the quiz, and this, of course, is where you actually submit it. It just makes it so much easier. Okay. Oh, chat. So this is due at 3 tomorrow. Yes, you noticed. So I give you until tomorrow at 3 p.m. So as always, if there's Oh, okay. I'm glad you. Okay, good. I thought maybe you didn't like that. I was like, what do you want from me? But if something happens technically or physically or job-wise or whatever the shit, just let me know. I can do like a makeup quiz or something if something happens, right? And remember, if something technically, you finish the quiz, you scan it, and it just won't upload, you can email it to me. And then keep trying to upload it. I like it. But the email will be proof that you finished it in time. Oh, good. You have all, everybody, yeah. There we go. Good for you, Garrett. That's right. All right. Anything else, guys? Everybody sure there's nothing else? No other questions? I'm pretty sure I graded almost everybody's 5.3, 5.4, 5.5. I tried to focus on that. I might have missed a couple, I don't know, but I try to get through all of them. Okay. So I'm going to do a little bit out of chapter 6, unless somebody has a question. No, okay. So let's get back into chapter 6 and something I want to show you. Let's see.
I have a question.
Yes.
So on the 5.6 homework, it asks for like local behavior and then end behavior. Can we just graph it on a calculator and then give you the answers, or do you want us to graph it out and then give you the answers?
No, no, no. You shouldn't. In fact, local and end behavior is something you should be able to tell by looking at the function. So let me see. 5, 6. Which one are you looking at?
It's like problem 25, 28.
Okay. So end behavior for rational functions. What's going to govern that? End behavior means let x get really big. And of course, what aspect of rational functions deals with x getting really big, negative, and positive?
The power of x.
Power of x. No. I think maybe you're in the right direction, but you're not saying enough. What is an asymptote? What's a horizontal asymptote about? I'm going to go ahead and give you the answer. So let's do this. All right. What would the horizontal asymptote be for, oh shit, where'd it go? Number 20. What situation am I in?
It would be 0.
Yeah, 20 would be y equals 0, correct? Does it, crap. I've got the book on the wrong screen, so give me a second. Reference my earlier note about old man and technology. Hold on. Do. Share that again. Okay. So I desperately need you to not forget. So you've got the 3 parts to the shortcut. And this is why I thought, Jason, you might have been on the right track, because it is about comparing powers. But what I really was looking for was the horizontal asymptote. What does this mean? What is this horizontal asymptote being y equals 0? What the hell does that mean? I mean, doesn't it have an X intercept? So here's y equals 0. Pretend like that's on the axis. There's y equals 0, right? Blah, blah. You're not going to make it better, Jeff. I know. So eventually it's got to approach that. But doesn't it go through it? Right there at negative 5. You can do it 1, 2, 3, 4, 5. It goes through that asymptote, doesn't it? What the shit? Why is that okay? Because the asymptote doesn't come into play until what?
Until x gets really, really big.
There you go. So that's, I don't know why I'm looking at this problem. This is not from the section, but anyway, it doesn't really matter. Forget that this says this. Maybe I should go to the actual right section, sorry. So the idea is, oh, Jeff, just do it this quick. Okay. Where's the section with those? There it is, okay. The idea behind a horizontal asymptote. So if I have a function like 1 over x, as x goes to infinity, f of x goes to 0, because 1 divided by really freaking big is really freaking small. In fact, in calculus, you're going to see this notation. The limit as x goes to infinity of 1 over x is 0. Becomes 0. So that's the one little extra thing you're going to see. You're not just going to see this as this. You're going to see the limit as x goes to infinity is 0. So that's the end behavior. End behavior is all about what's it do when x gets really big, positive, or big, negative. It goes to freaking 0. Is that all right? So end behavior for rational functions is going to be the horizontal or slant asymptote. What about local behavior? Well, what's it going to do at its intercept?
Isn't it where it changes direction?
Say one more time.
Isn't it where it changes the direction in the graph, like where it goes up or down?
Well, are you talking about where the vertical asymptote is?
Yeah.
Yeah, so we could talk about that also. So I was going to start with this, and then we can look at the vertical asymptote. So what is its behavior at the root? What would it do here? What's the multiplicity of this guy?
1. It's going to go through.
It's going to go through either that way or that way, it depends, right? So it's going to go through its root. And what's it going to do at its asymptote? What is its vertical asymptote?
Would it be negative 1/2?
Yes. Be a little more specific.
X equals negative 1/2?
Yeah, there you go. So then it's right there. So as x, and this is what Brian, I think this is what you're saying. I think it was Brian. As x approaches negative 1/2 from below, how do I tell what it's going to do? Let me write that better. That literally looks horrible. I know I can do better. Let's just start all over. Okay. Negative 1/2 from below. 2. Okay. From this side, which means what kind of numbers am I going to plug in?
Negatives.
Yeah, and like bigger negative than negative 1/2, right? So like negative 1. If I plug a negative 1 in, I'll get negative over negative. Is that right? Right? So that's positive. So it looks like it's going to go, f of x is going to go to positive infinity. So when I put in negative 1, I get negative 1 over negative 1, which is 1. So it looks like it's going to go like this. And then on this side, I can do the same thing, right? So I'd have to put in, oh, this side would be kind of gross. But the nice thing is, let me see if you guys are still with me here. There's always the shortcut that this is linear. So it's going to change signs on both sides of the undefined. So it's going to go like this. And then it's going to eventually come back down to its horizontal asymptote. We didn't even talk about the horizontal asymptote for this guy, did we? Oh, that was for this, Jeff. That's funny. What's this guy doing as x gets really big? This guy's horizontal asymptote. What situation am I in here?
1/2.
Yeah, y equals 1/2, because I'm in the situation where the powers are the same, the degrees. So it's the ratio of the coefficients. So it looks like this guy is going to be here and over there. Now, to be honest, you shouldn't have to, what am I trying to say? You shouldn't have to graph all this to get that from this. But I mean, you totally could. You could, but it's as you kind of figure out the graph, you answer these questions. So this is related to the horizontal asymptote. This, I would call it related to the intercepts, the X intercepts, and the vertical asymptote. Local means finite, and then end behavior is infinite. Is that better?
What if you have two vertical asymptotes, like number 28?
Oh, then you're going to have like more than one grouping of this. So just to finish this one out, as x goes to -1/2 from above, it looks like f of x is going to go to negative infinity. Is that all right?
I still don't get what you mean if it has two different vertical asymptotes. Like how?
All right, so now let's see. You're probably all very cool with me deleting all of this insanity. So let me do that. And we'll move down to where we have two vertical asymptotes. Somebody pick out for me a problem that has two vertical asymptotes.
28.
Yeah, okay. So 28. Pull you up a little bit. It's too late. All right. So let's just focus on the vertical asymptotes. So if I factor that bottom, what do I get?
X minus 5, x plus 1.
And just get out of there. What are you doing? Holy shit. And just to be careful, what do I have to be careful about? Why can't I just stop at this work I've done and be cool with it? Like they're both asymptotes. What do I have to check?
The numerator to make sure none of them cancel out.
Yeah, so if I factor the top, I'm going to get x minus 3, x minus 1, which is nice. That means neither one of these cancel, right? Because if they did, what would happen at that x value?
Open circle.
Open circle. I love it. How's everybody doing? So don't just look at the bottom when you're looking for vertical asymptotes, because you might have an open circle there instead of a full asymptote. Okay. So this will look like the, holy shit and a half. It's all right, just moving that, and I don't know why, holy macaroni. So there's my vertical asymptotes. So you're just gonna have to have, as x goes to -1 from below, as x goes to -1 from above, as x goes to 5 from below, as x goes to 5 from above, you're gonna have to have a pairing for each one, because you can attack it from both sides. How's everybody doing out there? So the nice way to do this, let me write this factored version out real quick. And we haven't even looked at the X intercepts yet, but that's all right. But I mean, real quick, the X intercepts, they're both multiplicities of 1, so it would go through each, right? You guys see that? It's going to go through each X intercept. That's the nice part. To investigate, can everybody mute themselves? Okay, thank you. To investigate this guy, this first pairing, is anybody not with me? This first pairing deals with this asymptote. So as my x's come in towards -1, what are my outputs doing? Well, let me just put -2 in. And actually, I know there's a x-intercept at 3. That's interesting, right? And there's an x-intercept at 1. So there's no x-intercepts back here. So it's either going to be fully up here, or it's going to be fully down there. So if I know where it is at -2, I know how it's approaching this thing. So if I, let me stop. I just always feel like I'm not quite got everybody with me, especially because I can't see most of you people. But that's all right. So if I put -2 in, I can see what side I'm on. And that tells me which infinity I'm going to. So if I put -2, I get negative times negative. I get positive on the top. And I get negative and negative, that's positive on the bottom. So it looks like I'm going, I just broke the law. I'm sorry. Don't report it. So as x goes to -1 from the left, my outputs go to positive infinity. And sometimes I'll tell my put the plus sign there just to be really sure that I know you know. Oh, I got a chat. Oh, okay. I know, I do that. If I lose you for a second, hopefully I'll get you back in one of the next seconds. And then the shortcut is it's going to change signs around this. In fact, doesn't this feel related to the work we were doing the other day? If I put all the zeros down and all the undefineds down, right? So here's the, let me see, what's the only one down here? -1, 0, 1, 2, 3, 4, 5. So -1. You remember doing this? We did this the other day, didn't we? Yesterday? There's a -1, it's undefined. At 5, it's undefined. At 3, it's 0. And at 1, it's 0. Aren't we basically doing that? So on this side, we figured out it was positive. Isn't it going to change signs here because everything's to a first power? It's just going to change signs, change signs, change signs, change signs. So what's that do for you, Jeff? Thank you so much. Well, it means on this side of 5, on this side, it's down here. So it's going to go to -infinity. So as x goes to 5 from below, it looks like f of x is going to go to -infinity. I can see that because it's negative. So it's down. And then on the other side, it's up. So as x goes to 5 from the right, the outputs go to infinity. Positive infinity. All right, let me stop for a minute. So this little dude is actually not a bad way to do these either, without having to actually fully graph the whole damn thing out. But to do this, you just have to have an idea. That's why the little u's are cool. But you really have to be able to see how this relates to the picture going up, going down, all that kind of stuff. Does that help at all? You guys doing all right out there? So it really is just this, the thing we were doing before with a little extra knowledge that I know it can't go through 0 unless it's got an asymptote or it's got, what do you call it? There it is, Jeff. An intercept, right? That's the only way it can go through 0 and change signs from negative to positive. So if I just look at one number on this side of the asymptote, I know which side it's on. And then I know how, if it's up here, it's going, if it's down here, it's going that. All right, that's enough. I'm not getting any more questions, and I don't have enough faces to tell if that's making sense. So I'm going to stop. Any other problems I can make worse? Or no, hopefully not. Any other problems I can explain in the wrong direction? I'm going to clear this. Please do, Jeff. Okay. All right. Anything else, guys? Did I miss anything here? Let me see. All right. Okay. So let's get back into 6 for a little bit. And then my intention is to let us out early. Let's see if I can stick to that. So 6 is all about exponential functions. So I want to show you something. Somebody give me an example of an exponential function. I take that as a no. Or somebody chatting at me. Give me an example of an exponential function.
How about 2 to the power of x?
Yeah, kick ass. That's a beautiful one because that's one of the simpler ones. I like it. So if I make a table of values for this, it's going to be really simple. Can somebody tell me what is the idea behind this function? What does it keep doing? So what the hell does that mean? If I make a table of values, I'm going to start at 0 just for, there's negatives I could throw in there, but I'm just going to start at 0 for some crazy reason. So what's 2 to the 0?
1.
1, think of 2 to the first is 2, 2 squared is 4, 2 cubed is 8. So you can very quickly tell this is not linear. If this was linear, what would have to be true? If this was a linear function, what would I see here?
The numbers would be the same distance apart.
Yeah, I would keep adding the same amount. So instead, what do I see happening?
It's doubled.
Yeah, I keep multiplying the same amount, right? So they're going to give you some tables. And actually, for some reason, they really like to write it like this. I always hated these kind of tables, but oh well. And they're going to have like 0, 1, 2, 3, whatever. And they're going to have like 100, 70, 49. Is that linear?
No.
No. Is it exponential? So not linear doesn't mean exponential. I can just put shit up there and it wouldn't be anything, right? How do you check to see this is truly exponential?
Well, 0 times itself, however many times, it only equals 0, so that doesn't make sense just to begin with.
Well, no, be careful, because if it's exponential, then that's in the power, right?
So could you divide 100 by 70 and then divide 70 by...
And do better than that. Divide 70 by 100. Because I'm thinking about what did I multiply this by to get here? And did I multiply by the same thing to get here? So what is 70 divided by 100?
It's 7 if you're going the other way around.
No.
7/10?
Yes. So I multiply by 0.7. And then if I multiply this by, and of course you could do 49 divided by 70, or you can multiply this by 0.7, and sure enough, it does give you 49. So it looks like it is exponential. So linear means you keep adding the same amount. And when I say add, that obviously means the thing I'm adding could be negative. So here I added negative 20, I added negative 20, that's linear. This one, I multiplied by 0.7, I multiplied by 0.7, that's exponential. Let me take this one step further. You stop for a minute, you guys cool with that. Linear, obviously, we know for a long time it means you keep adding the same amount. And that could be a negative amount. What might the function be? What might this function be? What's the base going to be? What is it that I keep multiplying by?
You keep multiplying by 0.7.
Yeah. And when I put a 0 in, 0.7 to 0 is 1, but I'm supposed to get 100 output. So what should be here?
Times 100.
Yeah. And then you can double check. 0.7 squared is 0.49 times 100 is 49. Yay. Maybe. So I think.
Can you go over one more time how you got 0.7? Did you divide?
Yes, I did. I did 70 divided by 100.
I see that now. Thank you.
And why does that make sense? Your brain might still have a part of it go, you can't do 70 divided by 100, human. sane? And we're like, brain, calm the hell down. Of course we can. We get freaking decibels. We give a shit. So you always would go where I went and where I started. You compare it that way. So how did I figure out negative 20? 80 minus 100. So that's what I must have added to 100 to get to 80. So I got to do this divided by this to see how I move that way. Is that? I like it. So this would be an example of exponential decay, right? Sort of like Chernobyl, or radiation, or your car depreciating as you drive off the lot. Okay. Maybe. So there will be some homework problems that look like this. And just because it isn't one means it's the other one. Because I could just made numbers up and then it's nothing. Okay. Let's see, what was the other thing I want to talk about? Oh yeah. There is a really, oh, somebody chatting at me? Oh, somebody had to bounce. Okay. There's a really silly place where we see something come from. Let me show you this real quick. Here's basically the form that I just used, right? Where A was 100 and B was 0.7, that's the problem we just did. Now, here's a little something that really makes me sad. If you had this function, is that this? Are those the same?
No.
Good. The correct answer is hell no.
Hell no.
Very good. Thank you. I will accept that amendment. Get that shit out of here. That doesn't make any damn sense. So let me show you with some examples. 5 times 2 cubed. How many 5s are up here?
1.
1.
How many are up there?
3.
How the hell would you make 3 10s from 3 2s and 1 5? Do you get the idea? So don't do that. Don't do that. That's right on par with saying the square root of x squared plus 4 equals x plus 2. Ah! That's insane. Stop. Okay. Why is that insane? Is anybody like, wait a minute, what's he talking about? Of course that's true. If you are, I know you should probably, you're not going to say anything, but square roots cannot go across addition. They don't play well together, right? It's the same reason why a plus b squared is not a squared plus b squared. Because exponents do not distribute across addition because exponents are not based on addition. Is that cool? Sorry, I kind of went off on a whole side trip there. Sorry, I'll stop. I just started, what's all the shit that drives me crazy? No, stop. Okay, so be careful about that. You cannot put these together. There's x2s and 1 5. You can't make any 10s out of that. To be honest, you could, but it gets screwed. I'm not going to do it. What was the other thing? One last thing, and then I'll let us out of here. Yeah. This is perfect. Okay. The last thing I want to talk about. There's this function in the book. Let me see if I can use the same format. It's the compound interest formula. Where are you? And they give it to you in the homework. They give it to you in the book. I want to use the same. I can't remember if they call it f of x. Oh, screw it. I can't find it. Or is it a of x? Here it is.
Yeah,
Oh, okay. A of t. I knew there was something different. Okay. All right, let's make heads or tails out of this shit. Does anyone deal with finances in a larger way than just your own? Do you know about compounded annually, compounded semi-annually? What does annually mean? That means how many times a year, obviously.
once.
Once.
What does semi-annually mean?
Is it
That's
a
a little-
quarter?
No, that's quarterly. Quarterly
Oh.
is remarkably enough 4 times a year. Semi-annually is twice a year. Then you got quarterly. Then of course you got monthly, which if you don't know what that is, then I don't know what to do for you. And then you have daily. If you have a problem where it says daily, assume there's
365. Oh.
Sorry, say.
No, I said 365, but never mind.
Yeah, just go with 360. Just because we're not going to see too many of those anyway. So what is this? What is this all about? So if I have like a 7% account and I do it quarterly, so every quarter I'm going to increase. I'm going to add interest on, but it should be 7% for the year. So it should kind of make sense that what I do is, well, actually, I don't even know if you guys kind of know where this comes from with simple interest. But this is not a business class. I'm only going to explain the basics of this. So it should kind of make sense. I'm going to cut 7% in 4 parts because I'm going to do it 4 times over the year, and I can only have 7% for the full year. And again, I'm not going to teach business. Ain't no freaking way. So this would be whatever money I put in times 1 plus 0.07 divided by 4 if I'm doing it quarterly, to the 4 times however many years I'll leave it in. So you're going to see some problems like this in the homework, and it's basically going to be plug shit in, throw it in the calculator, get the answer. They just want to show you some real life examples. So here's the stupid thing. I don't know if you guys want that. They don't really write this in the book, which is evil. I think, no, they do somewhere. Yeah, I remember. They do put this somewhere in the book. Okay. So now watch this. Watch this. It's kind of nifty. Look at this. Let me just focus on. Let's pretend like I put $1. Right? I put $1. I go to the bank, and I make a big scene. I'm like, somebody better help me out. And they finally come over. I'm like, I want to put this dollar down. Holy shit. So if I put $1 in there, $1, and let's say it's my 7% account. Why not? Yeah. And it doesn't want that. Yeah, let's do it for 1 year. There you go. Sure. So it's $1 and it's 1 year. Now watch. No, think about it. N is basically how am I chopping the year up? So I went all the way down to monthly, and then I went to daily. But can't I go by hourly? Couldn't I do it hourly? How many hours are in a year, roughly? If I assume 360 days, how many hours are in a year? How would you calculate that? Could you calculate that?
Siri said 8,765 hours.
Oh my goodness.
With only 360, isn't it 8,640?
All right, well, we'll take the more correct one. So, and by the way, real quick, ask Siri. No, wait. Don't ask Siri shit. I want you to ask her in a second. The number of seconds in a year is pi times 10 to the 7th, approximately. Is that weird? Some of you guys are frozen. Is it my Wi-Fi, or are you just not moving? Can you guys move a little bit? There's Jason. I see him. All right. All right, go ahead and ask Siri how many seconds are in a year. I like this. Are you doing it? Let's see.
She said 31,556,952.
367. Isn't pi 3.14 roughly? So there are roughly pi times 10 to the 7th seconds in a year. That's a major side note. Sorry. But there's a nifty thing they do in the book, and I'll show it to you. Last thing. Let me pull this up here a little bit. So what if, so now listen, I could do it per second. Could I then do it per half second? Could I then do it per quarter second? Could I then do it per 1/10 of a second? And then I could freaking do it eventually per moment, right? I can go down to the quantum level of this shit. What a weird bank. So what's the limit as n goes to infinity of this? Do you understand how that relates to what I'm doing? Keep cutting the year up into infinite parts. Yeah? Maybe? No? I'm not trying to remember if it had to be. Yeah, it did, Jeff. That's all right. Let me change one thing. It has to be this for this to work. This is the, sorry I changed that up, I don't care. This is the stupidest place where E comes from. It's still kind of neat. The number E comes from this process. The cooler place, and you guys have all seen E before, right? Yes? Have you guys worked with E before? And you're all like, is this a drug?
Yeah.
Okay.
It needs.
E squared and E cubed and all that kind of shit. Is it on my shirt? No, I'm not wearing that shirt today. The cooler place that E comes from is if I graph the graph 1 over x. If I graph that part, I know it's over here too, I don't care. And if I start at, now just go with me, this is really cool. Very much. If I start at 1, how far do I have to go until this area is 1? Now some of you guys are like, that's cool, Jeff? Well, what's cool is, if I go up to E, the area here is exactly 1. You can, don't pretend that it's cool, but I'm hoping maybe somebody out there is like, that's kind of interesting. Doesn't that number then seem to deserve something? It does this shit, it does this shit. It's like, all right, we're gonna give it a letter, just like pi. It does some nifty shit. So here's the page in the book. And then this will be it. I'll let you guys out of here. What page is this? I don't even say pages. Oh, well. Evaluating functions with base E. They go through this step by step. They let n go really, really big. And here's that number. They approximated it that Siri gave us. And there's basically what E is. 2.71828, blah, 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 just like pi. Right? And also this tells you annually is 1, time of year, semi-annually is 2, quarterly is 4. So that's a good place to reference. And here you can see they did daily. Well, they did 365, didn't they? Oh, well. Too bad for me. Okay. So I think that's enough. So what I'm going to do, what I need to do, since I've decided to give us a little bit of the class off, I need to go open the quiz up for you in case anybody wants to start it right now. So I'm going to go do that right now. Class is over, so you could leave right now if you want to. Somebody took me up on that offer quick. Let me open the quiz. Have until tomorrow at 3. Is it open already? No, 10 more minutes. Let me change that. All right, there you go. So now it should be accessible. So if somebody wants to start it now and you want to make sure you can access it, go ahead. Let's see. And again, it's in the same place all the other quizzes were. The module called quizzes. Is everybody else all right? You guys have any questions about anything?
I
Okay.
have a question,
Yeah.
Professor. Sorry. So for example, on the practice sections, for like for example, yeah, if I want to find the zeros, I can also factor by grouping, right? Or do I have to forcefully use synthetic division and then go from there?
Oh, there's a, oh yeah, wait. At some point, you might start with synthetic and then you just transfer to factoring the minute it becomes something you can see. Like it could be a cubic, but grouping works. Then you can just stop doing synthetic and do the grouping.
Okay, yeah, because I was doing the homework for 5.3. When was this? Monday? No, not Monday. Monday was yesterday. Sunday. And they did like some weird where it's like x cubed plus like 2x squared plus like it doesn't have a like it has a missing term and then it just has the like plus 6 for example. So I still get confused.
Oh, well, that one you have to use synthetic. We don't have any process to work for that besides something that somebody insane, a mathematician called Cardano, created, and it's a really, really, really gross.
Okay, but if I'm missing a term, I have to put in a 0.
You have to put in a 0, and then almost definitely you can't directly factor it. You're going to have to do another synthetic.
Okay, and then all right then yeah, and then for that I have to list all the possible outcomes, right? Like plus or minus 1 and 2 and 3 and then a half or whatever the numbers are.
Yeah, if it says if it says you got to use the rational zero theorem and find all the zeros, then you need to start by listing all the things you're going to be able to try, which is all the possible rational zeros.
Okay, all right, that sounds good.
You don't start there. You don't even know what your guesses should be, right?
Yeah, okay. Alrighty, sounds good. Thank you.
Let's see. How's everybody else? Sylvia, Doug, Zach?
I think I'm good now after listening to the last one. Thank you.
Okay, you're welcome. Doug, are you out there? You okay? I hear something. Are you okay out there? Oh, okay. I'm going to head out if you don't have any questions. Are you good? Okay. Take care of it.